I woke up around the same time.
Oh,
Yeah, I just set the alarm on 6:30. I couldn't wake up by 6:30 a.m. Then I suddenly just woke up by 8:10.
mm,
Yeah. And now that's gonna be the case number 3 in the process that we're solving the logarithmic inequalities. So far we talked about the cases that the bases are the same, and we saw that it's very easy example. We talked about the case when the bases are different, then we used, I should say, property number 7 to make the cases to be equal. And now we're talking about the cases that we have multiple terms. Okay, and now we have this one. Mingzhe, how about if we just give it a try for a couple of seconds?
sorry?
How about if you just give it some thought before we move on?
Uh, mm,
This is going to be this inequality. Okay. Okay, did you solve it?
I don't know how to solve this.
How to solve this? Okay,
Yeah.
that's a good thing, Mingzhe, because now we can just, that's why you are here, to learn how to solve this kind of stuff. Okay, Mingzhe, if you remember yesterday, the cases that we talked about was like that. For example, if I just want to review the case that we talked about that yesterday, we talked about the cases like that, you see the paper fine?
Yeah.
We talked about the cases like that. For example, with the case number 1, the case number 1, we had these kind of cases that we had the log, for example, of, for example, the function f of x. It was, for example, greater or equal than the log of another function, which we call that g of x. And we said that the base for both of them was essentially the same. This was case number 1. We talked about that yesterday, huh? In
Mm,
this case, we saw that it was a very simple, the most simplest case of the logarithmic inequality, and they only arises when they have the same basis. You see, when we have the same basis, it's going to be the most simple cases. Then we said that the f of x holds the responsibility of this inequality when the basis of these two log functions are the same. Then the f of x should be greater or equal than the g of x itself. That's right.
yeah.
That was exactly the thing that we covered yesterday. And we said that it is going to be the easiest cases in, I should say, the logarithmic inequalities. It was for case number 1, correct?
Mm,
But for case number 2, we had the case that we said that, okay, in the other cases, we may have, for example, the log of f of x, its base, for example, b, is greater or less than, for example, the log of g of x, when the base is a. And we saw that yesterday that when the bases are different, for example, we have the base b here, and we have the base a here, these things cannot be, I should say, in this case, we cannot hold the driving functions f of x and g of x responsible for this inequality as we did in the previous case. The case was how to do this one. I call this case number 2. We saw that the best one is that either take both sides using property number 7. Property number 7 was what? Property number,
change the base.
that's right. It was log. For example, we said that imagine we have the log x with the base a. We can change the base, go into the log. The desired base is going to be, I call this b, for both of them b. X goes on the top and old log goes on the bottom. It was property number 7 of the logarithms that we learned, huh? Property number 7. For this case number 2, we just consider the case that we transfer these two logs into a base which is common for both. For example, we had the case of yesterday, base, one of them was 7, the other one was 5. We took them both to the base of 10, which it was easier to work with. Also, the other case is possible that we can just, for example, transfer them both to one case, keep one case fixed, for example, to the base 5, and transfer the other one to the case when the base is 7. That was a thing that we discovered yesterday. But going back to the thing which we have here, to the case that we have here right now, the case, if, guys, if you want to, Ninja, Sean, and Arya, are you here? If we want to compare this case number 3 with case number 1 and case number 2, which category we can just put them inside? Case number 1 or case number 2?
Number 1.
Number 1, that's right, because we have the bases of these two logs to be exactly equal. Huh?
Yeah.
Then in that case, we can just find it at the subcategory of case number 1. But now, look at, but there is a problem. The problem here with that, Ninja, is that when you look at this, you will see that we have now 2 terms. And the other side is 6. It means that I cannot take this one to the other side and say, okay, then I compare, for example, these two logs together and I hold those two driving functions responsible for it. Because if I take it to the other side, I have 6 minus log x, and the whole log is going to the power 2. That's right?
Yeah.
Then the problem which it caused here right now is that these type of logarithmic function, the problem which they create is that I cannot just make them uniform like this. Although they are in the category of 1, but I have multiple terms, right? But how to deal with these cases? With these cases, the way which we are going to deal with these cases is this. Let me write it back once more here. It was log x plus log x basis 2, and it goes to the power 2 greater than 6. Correct? That's the law. I know. I noticed that I have multiple terms, but we have done something very similar a couple of, I should say, sessions before. That we said that imagine that if we transform one of the logs, I mean, if we can just hide, I just, when I learned this kind of methods myself, I learned it in a way that I said that I'm just going to play hide and seek with this type of logarithmic functions. Have you played hide and seek?
No.
You hide yourself somewhere and someone has to find you.
Oh, I played before.
Yeah, that's right.
Yeah.
This is the strategy which we have for these type of functions. I call that hide and seek. Hide means that you hide yourself and then someone comes to find you. Hide and seek game. What do I mean by that? The first thing is that imagine that if I hide the log x with the base 2, into something different. I hide log x2 into what? Into, for example, y, correct? You see that, people? Mingzhi, Sean, Arya? I say that if I hide log x with the base 2 into y, how these functions may look like. If I want to rewrite this function, I'm going to come to the first term, the log x with the base 2. I'm going to hide it with the terms y. Then it means that if I want to rewrite this equation, what should I do? I just put y instead of log x2. That's correct, Mingzhi, Sean, Arya?
Yeah.
Yeah?
Yeah.
Then what's going to happen? It means that, okay, I start from left going to the left to the right. Then I see log x with base 2. It means that I'm just going to play hide and seek. I'm going to hide log x with the base 2 with the y, correct?
Yeah.
And I see the plus sign, plus. I see exactly the same term, log x with the base 2. It becomes what? Becomes y again, but I
Square.
am careful, huh?
Square.
Say what?
With the power 2.
That's so true. Thanks,
Okay.
Mingzhi. With the power 2, becomes what? Becomes greater than 6. Huh? That's
Yeah.
still, we are at the part of the hide. We are hiding, but still we haven't done the seeking yet. So somebody has to come to find what is y. Okay, then you see that as a step number 1, I'm going to write here step number 1. As a step number 1, what did I do? I just came here to hide my log functions with another variable, which is y, and rewrite the equation, correct? And now that we are in this very simplified stage, because you can make a comparisons, guys, between equation number 2, if I call this equation number 2, and equation number 1, which one is easier to look at it, to analyze it and solve it?
Number 2.
That's number 2, that's correct. Then the thing which I'm going to do is this. I'm going to come here and say, okay, I'm going to work and put all my energy and focus on this equation first. What does it mean? I can come rewrite this equation. I can come to rewrite it as this, as y squared plus y minus 6 should be greater than 0, correct? This is going to be my principal equation at this stage. Correct? I took 6 to the other side, and I'm just going to write this equation like this. Okay, now. And what's the problem now? How can we just solve this inequality? But this equation reminds you of what kind of equation? Quadratic equation, huh?
Yeah.
That's right. Okay, how to just solve the inequality for this quadratic function?
Y plus 3, y minus 2.
That's right. You just, you first of all, you write it like that. You say it can be transferred to this form, that y minus 3
Plus 3.
plus 3
Yeah.
times y minus 2 should be greater than 0, correct? Because both of them, if you multiply them, you get minus 6. If you sum them, you get plus 1. That's correct. Okay, how to solve this inequality, Mingzhi, Sean, Arya?
Y plus 3 greater than 0 and y minus 2 is greater than 0.
Is it possible that both of them should be less than 0? That they should be minus, then when you multiply them, then you still become positive? You see, they have more options then, huh?
Yeah.
That's right. Then the best way to solve these inequalities is what? Is, let me go to the next page. It's going to be page number 2. It was my page number 1. Okay. In order to solve these inequalities, I'm just going to write this here. The equation was reduced to y plus 3 times y minus 2 had to be greater than 0, correct? Okay, now we have this equation. When you want to solve this equation, what needs to be done in terms of the inequality? The first step is what? To solve the equation for its 0 point. You see that if you want to solve this equation, guys, for its roots, what do you get? You get y plus 3 times y minus 2 equals to 0. Then as a result, what are going to be the roots? It's going to be y equals to plus 2 and y equals to minus 3, correct? These are the roots of this inequality. I said temporarily, I just take this inequality, become an equality to become 0, correct?
Yeah.
Then when I get the roots, I'm going to do this. I don't know if you have done that before or not, but in case if you haven't, just it's the basic method that we use. We say you're just going to draw an x-axis, which the x-axis has a 0 point, huh? Correct?
Yeah.
Then I just come here to plot my points, which is 2 and minus 3 on this axis. It's evident that plus 2 is going to be here, and minus 3, this is going to be on the left of 0, correct? And I have 0, and I have these 2. Then you see that I make some kind of boundaries between these 2 points. And this is going to be the chart which I make. And I know that the other side, it holds my inequality. This is going to be y plus 3 times y minus 2. Correct? Everything is so far? It's so far so good?
So far, so good.
Awesome. Okay, at minus 3 and plus 2, what is the behavior of this function? It becomes 0, huh?
Yeah.
Because these are the roots. Then I put 0 on them. You see? I put 0 on them. But however, what happens between these regions? Let me have a pencil. Look at this Mingzhe Shan area. You see this area? Yes?
It's Brian.
So, Brian, is it you? Brian? Okay. Look at that. I need to fill, you see the squares, the areas which I shaded. You see that? These are essentially part of the x-axis, which shows the behavior of the function. Imagine I am in the interval between minus 3 and plus 2, Mingzhi, Brian, and Sean. I'm in this interval between the roots of this function. Mingzhi, pick up one number in this interval.
-1.
-1.
Yeah.
If you plug -1 into your function, what happens? What is the sign? -1 plus 3 becomes how much?
Plus 2.
Plus 2 times -1 minus 2 becomes how much?
-3.
-3. You have
Yeah.
-3 here, you have plus 2 there. Negative 3 times plus 2, how much it becomes?
-6.
Negative 6. And what is the sign of it? This is negative, huh?
Yeah.
Then we say that because of this, we take it as a sample, which it means that in this interval, the sign, it's going to be negative, correct?
Yeah.
That's right. It's going to be negative. Because you take a sample, one sample in this interval decides on the entire interval in terms of the sign. You can also come with 0. You see, if you put 0 in this interval, you get 3 times -2 becomes -6. And at these boundaries, it becomes 0, and we decide on the whole interval. But how about the interval? If x is greater than +2, it means that on this line, we are starting to move towards the right. X is greater than +2. For example, pick up a number which is greater than +2.
5.
5. If you put 5 in this equation, 5 plus 3 becomes how much?
8.
8. 5 minus 2 becomes
3.
3. Then 8 times 3 becomes what?
24.
24. Is it a positive number or minus number?
It's a positive number.
Positive number. Then only one single number decides on the sign of any other number in this interval. But there is one interval which is left, which is x is less than -3 on the other side of the x. Then, for example, on this interval, pick up a number which is going to be less than, oh no, less becomes here, becomes less than -3, which means that it goes to -infinity.
Minus 10.
-10.
Yeah.
-10 plus 3 becomes how much?
-7.
-7. -3 minus 2.
-9.
-9.
Negative 12.
That's right, -12.
Yeah.
-12 times -7.
Negative 84.
Negative times negative becomes plus, huh?
Oh yeah. 84.
That's right, 8 plus 84. Then the sign is positive when we take one number as a sample to show that the entire interval gives you a positive number, correct?
Yeah.
Okay, and now you will see that I was able to find everyone, Brian, Sean, and Mingje. I was able to find three, I should say, in this interval, three different, I should say, numbers then, which it means what? It means that then at the interval from +2 to +infinity, the function is positive. At +2 and -3 is 0, but at from -3 to +2 interval, it becomes negative, and from, I should say, -infinity to -3, it is again positive. You see how it works? How did I constructed my chart?
Yeah.
That's right. And
Yeah.
now, please go back to the same question as you had. The question was what? The question was this one, that this inequality has to be positive. You see that? This inequality had to be positive. This inequality has to be positive. It means this one. The same thing which we decided on the sign of it. Yes, Sean?
Yes.
Yes, David? Oh, sorry, Brian? Is it Brian there, guys?
Yes, Brian Z.
Brian Z. And Mingje. Yes, Mingje?
Yeah.
That's right. Then the thing which I did essentially here, I was trying to find the sign of these ones. Then if I'm going back to the same problem, that it says that x plus 3 times y plus 3 times y minus 2 has to be positive, that's essentially the same thing. That's how we decide that this function is positive in these two intervals, right? Right, guys?
Yeah.
Hello? Everyone's there?
Yeah.
Awesome. Okay, what's going to be the next step, guys? Hello? Okay, so far we decided on the sign of it then. And now, then as a comparison, as a logic at the end, I can say I can pick up these two intervals. That's right.
Yeah.
These two intervals. Sorry, I had to just, I couldn't put X there, guys. Sorry, I had to put Y because my variable is Y. Then you see that if Y belongs to this interval, plus 2 goes all the way to infinity, and Y in this interval of minus infinity to minus 3, then these are the intervals which I require that for the case to have this one to be positive, because I decided Y on this
Sir?
interval gives a positive sign. Any question?
Can you hear me now?
Yes, Brian, is it you?
Yeah.
Yeah, I can hear you.
I
Great.
changed my headphone.
Okay, that's great. That's great. Thanks. Brian, if you missed some part of the beginning of the session, I'm just gonna, it is recorded, and I'm just gonna post a note on the Schoology website to let you know the link to watch the
Yeah,
video.
I'm in this class since 9:10, so
Oh, okay,
I
okay,
think I
right
didn't
time to
miss
join it.
anything. Yeah.
I think that's fine then. Fantastic. Fantastic. Thanks.
Yeah.
Then now, guys, I decided that these two intervals gives Y in this interval, it satisfies this requirement. That's right. Then it means that Y should be greater than 2 and Y should be less than minus 3. So far, so good. No questions?
No questions.
No questions.
No.
And now I have decided about the Y, but the problem is that, guys, I just made a hide and seek game, and I said that my Y is this function. Then now I'm gonna just, I was hiding the Y right now, log x2, and now I'm gonna through the seek to find it. Now the game is gonna be completed. How to do that? On the first case, I call that case A. I say Y should be greater than 2. Y should be greater than 2, correct? But what does it mean when we said that the Y is greater than 2? What was Y before? We said our Y is what? This is the log of x with the base 2, correct?
Yeah.
That's right. Then if Y is greater than 2, I'm gonna seek Y. I was playing hide and seek. Initially, I hid log x base 2 with the Y, and now I find it. It means that I put log x by base 2 back to its Y, which it means what? Means the log x with base 2 is greater than 2. You saw what happened? Yes, everyone?
Yeah.
Yeah. And now that I have this one, and now I try to solve again this simplified version. My task right now is that to solve this very simplified version. Guys, I'm just gonna give you 1 minute, everyone individually, you try to see if you can solve this inequality before I just move on to solve it. And the task now is that to solve this one first. Okay, are you done? Sean, Mingji, Brian? Sean, Mingji, Brian?
Yes.
Are you done?
Yes.
Nice.
Where is Samantha?
Samantha is not in the
No,
group?
she's not here.
Let me see.
What happened to her?
I have no idea.
Oh, she's late to the class.
Yeah. And
Yeah.
also,
Weird. And also the others.
that's right.
Oliver.
Guys, that's a beautiful day today, huh?
Yes.
Yeah. What time did you wake up, Sean?
9:06. Oh, yeah. And
What time did you go to bed?
lazy. Stay at home to be lazy.
That's so true. What time did you go to bed?
Oh, at 1 a.m.
Oh my goodness. What have you been doing by then?
Oh, I just started at 1 and play some Rubik's Cube.
Ah.
Yeah.
How about you, Brian?
When do I get up?
That's right.
9.
9. Sharp before the class.
Yeah.
That's right. I think staying home during these, I should say, isolation days, it's so hard to
Yeah.
wake up on time. It makes you just, stay more in bed.
Yeah.
That's
Yes.
right.
Yeah.
Okay.
Okay.
Now, Mingji, are you done with the?
Not yet.
Not yet. We give it one more minute. Brian, how about you? Are you done?
No, I'm working on it.
Ah. The weather today is so gorgeous.
Yeah, cloudy.
That's right. I just woke up today. I just went to the balcony as soon as I woke up. Oh my God, the energy was so much. It was so good. It felt so
When
good.
did you get up?
Me, like Minji, I woke up around 8:10.
Oh, that's so nice.
I put the alarm. I put the alarm for 6:30, but I was lazy today. 6:30, the alarm just went off, and I had to shut it down. I went back to bed. I woke up later.
Oh.
Well,
But
my
the plan
alarm
was
is on the
Testing.
7.
Huh?
My alarm should wake me on 7. And I
you
just get up on 9.
and you shut the alarm off and you went back to bed?
Yeah. I
That's-
shot it twice. One on 7, one on 8.
That's so true. It's so hard. It's so hard to wake up early. When I used to just go to school, I used to wake up way earlier by 6:30.
Yeah, me too.
That's right. But now, look, I wake up by 8, and still I have so much difficulty to just pull up myself from the bed. I had to go to the balcony to take a fresh air into my lungs to wake me up. That's right. But a beautiful day.
Beautiful. That's so true.
That's right. Let me open the window. Speaking of the fresh air, let me open the window. Come back in a second. Guys, it seems that next week is gonna be the midterm
Yeah, it seems that.
tests.
Midterm test.
Tomorrow, I assign the date, the sharp date of the time that we have to run the test. I do not know if the school is closed on Friday. Minji asked me yesterday. I checked it.
The school will won't have the online online classes on this Friday and next Monday.
Oh, they don't have classes?
Yeah, this is what Mary said.
Are you sure?
Yeah, on Friday we don't have class.
Yeah,
And also
Monday.
next Friday.
Next Monday.
Monday,
Who said next Monday?
Friday and Monday, huh?
Yeah,
Oh, nice. Interesting, huh? Guys, are you happy?
yeah.
This Friday and next Friday, because next Friday is Easter Day.
This Friday.
No, I think, Sean, this is this Friday.
Oh, this Friday is Easter Day.
And Monday is going to be the Monday after the Easter.
Yeah.
But regardless of that, guy, I'm going to check that again. I'm so happy myself, but I have to tell you, we can sleep longer, huh?
But Priscilla told us we also do not have class on next Friday.
Oh, I have to check that myself then. Let's
Yes.
see. Interesting news coming up. Okay, guys. Let's solve this one. Then let's see what happens. But that's a good thing. I hope that we can have enough sleep and at the same time study more. Okay, this Friday, Monday, and next Friday. Okay, guys. Let's do this one. I'm gonna work on this and let's see what happens. Guys, you remember that yesterday when we were working on one of those problems, I said that whenever you see number 1, the best thing to do with that is that log, for example, the log number 1, when you're working in the logarithmic space, whenever you see 1, it reminds you of what? It reminds you of the property number 1 that we said it shows the log of number at the same base. Remember that? Then as a result, I'm gonna do the same thing. When I see the log of x with base 2 greater than 2, I can do what? I can come and say that. I can write it in a way it shows that. It becomes the log of x in base 2 is greater than 2 times 1. Can I write that like that?
Yeah.
That's right. Then in that case, can I replace 1 with a log term?
Yes.
Because, guys, remember, in the logarithmic space, always 1 represents to a log term. Whenever you see 1, it takes you to this identity. It was property number 1, correct? Property 1 out of 7. Then when we are at this stage, I can replace 1 by this. Then I can write the log of x with base 2 is greater than 2 times of log. What is the basis going to be then?
2.
2, that's right, because I am careful at the same time to not give myself so much headache. Yes, Brian? Because if I choose any other basis than 2, then the problem is that then at the end I have to use property number 7 in order to change the base and make the bases common, right? Then at the same time, without going to such a long way and give myself a headache, as Minje said, I put the base 2. Then you see these two bases are what? Are similar, huh? Then at the same time, what is going to be the main drivers of this?
2.
2, that's right, because the base of 2 with respect to 2 becomes 1. But guys, there's one more problem. There is one number 2 loitering behind the log function. What is that? How can I just solve this? How can I resolve it? Can I use property number 3 and I say that I can take this one going as a hat to this number 2? Can I do that?
Yeah.
Yes. Then in that case becomes what?
Log 2, log 4,
That's right.
4
Becomes
over 2.
log, so true, becomes 2 over 2. 2 by the power 2 becomes 4. And I have my base here. Correct? Brian,
Yeah, I'm
you're
listening.
fine?
Yeah, I think.
Are you sure?
so. Yeah.
Awesome. And now, guys, Mingzhi, Sean, Brian, you see, we reduced these log functions after taking some interesting steps to the case number 1. That in case number 1, as we talked about that, we have the inequality with the same basis. And we hold the main functions responsible for this inequality, right? Then as a result, as a final step, I can say that, okay, if that's going to be the case, x is going to be what? Is greater than 4.
4.
Correct? Because x and 4, and I hold the main drivers as a responsible for this inequality. Correct? Any questions?
No.
No?
Mm.
Okay. Brian, Sean, Mingji, no questions?
Not
No
really.
question.
Okay.
Yeah.
And now, guys, we did the first time. We did the first thing. What did we do so far? The thing was that we started from equation number 1, which it was a log function, log inequality. We hide log x with base 2 with y. Then we ended up, for this inequality, we ended up 2 arguments. Y is greater than 2 and y should be less than minus 3. Correct? I'm going to call this case B. For case A, that y should be greater than 2, we ended up with these using property number 1 and property number 3 to get to the fact that x should be greater than 4 to make the inequality valid. But how about case B? Because they are valid both at the same time. Y should be greater than 2, and at the same time, y should be less than minus 3. Correct? Then I'm just going to ask you, please, do case number B yourself. Start case number B, then I do that together. For case number B, your y should be less than minus 3. But what is y? Y is log x with base 2. Make sense?
Yeah.
Yeah, please do that. Let's see how far you go. Guys, in case if you want to just really, Sean said he just wants to attend for that mathematical modeling challenge. In case Brian and Minji, if you want to do that also, you are so lucky because all the things which you need for that contest is the knowledge of the exponential functions and logarithmic functions in order to make the modeling. Then you're at a very advantageous point because you have the basic knowledge to just go for that challenge. And you're given real life problems to use these models to solve them. It's a very good thing. I recommend you take part in it.
I also recommend Samantha.
You what?
I recommend Samantha to join the competition.
And also, I think Mingji and Brian also can do a great job in that contest if they want to go for it. Okay. I give you 2 minutes, guys. Is it good to work on it 2 minutes? What was it? Page number 4 comes here. Page number 5. Oh my God, today is so beautiful. It has a very interesting energy today. Okay. Are you done, guys? You don't mind if I start and you follow me and you help me how to do that?
Mm.
Guys?
Yeah.
Brian, Sean?
Yeah.
Are you done or?
I'm done.
You're done. Great. How
Yeah.
about you, Brian?
Maybe I need to learn more.
Okay. How about we just start in 1 minute, then you can help me in case if you are not done in 1 minute, huh?
Okay.
Awesome. Mingji,
Yeah.
you don't want to just go for that challenge?
The math contest.
Yeah, just go for it because you have covered the log functions, exponential functions, inequality of the log functions, and you are a big good knowledge. You have a good knowledge for that contest. I recommend you do that because it helps you a lot when you just apply for universities. It's a good thing on your application.
When is the contest?
The registration ends by April 21st, and I think in 2 months, I think probably it's going to be the contest.
Oh, in
And it's
2 months.
online. In 1 month or 2 months.
Oh.
Then you have enough knowledge for it, then it's a pity because it helps you a lot when you just want to apply for university, and it's just a good thing on your application. And also, Brian, the same thing for you. Just think of it and let me know tomorrow.
Okay.
The reason which I'm persistent on it because it seriously helps for your admission to top universities. They said that, okay, you are very active in terms of going for challenges and contests in the math. And I think it has a very good impact on your future. Yes, Sean?
Yes.
And let me, Minje and Brian, let me know tomorrow.
Okay.
Yeah, but I highly recommend you to do that because it is good for your future, your academic in universities. You can chase the top universities to apply to. Okay. Now, Brian, is it a good time that we just start and you help me? Are you done?
Maybe you can start your.
Yeah, but you help me. Yeah?
Huh?
Yeah, you help me, please. How to do that?
Yeah.
Okay, so we had hidden y with what? With log of x with base 2, correct? Yes, Brian? then in that case, it means that if y is less than minus 3, it means that it is going to be the log of x with base 2 should be less than minus 3. Correct? Yes, Brian?
Yeah.
But the point is that I'm going to write 3 minus 3 as minus 3. Guys, that's a very important step in the logarithmic equations or inequalities. Give me 1 second. And is that whenever you have, and the key, the golden rule, guys, is that whenever you have a minus, whenever you have a number, you can always turn it into a logarithmic shape by multiplying it to 1, correct? And you substitute 1 with the log of the same base. What does it mean? It means that you can rewrite all of this in this format. To write the log of x with base 2 is going to be less than minus 3 times log of what? 2 with the base 2. Correct, Brian?
Yeah.
Right? Brian?
Yeah, I'm listening.
Is it good so far?
I think so.
That's right. Are you sure or you think so? Which part confuses
Because
you?
I had to say, to be honest, I have been absent for many times just because I can't wake up, and maybe some basic knowledge I don't know, so it's quite hard for me.
Maybe you missed some
I'm
properties.
sorry. So
Then,
yeah.
I got it.
I'm
Brian,
just
then please check the videos which
sorry.
we have. Huh?
Okay. Yeah.
Yeah?
Yeah. I learn by myself. Trying
That's right.
to
And
follow
also
you.
at the same time, I recommend you check the videos, and I'm going to introduce some online sources. I'm going to put that on the Schoology. It's a good sources also. You can follow them, huh?
Yeah.
Yeah?
Okay.
Then as a
Yeah.
result, when we are here, Brian, Mingje, and Sean, because we have minus 3, I can take minus 3 as a hat for 2. Then it becomes what? Then at the end, I do get what? I get the log of x with base 2 is going to be less than the log of 2 to what power? Minus 3.
Negative 3.
That's so true with the same base. What is 2 to the power minus 3?
1/8.
That's so true, because why? Before I just move on to that stage, it's better to just get rid of the bases. Look at this one. I have base 2, I have base 2, and I have 2 logs on both sides of the inequality side. Then I can hold the drivers responsible for this, correct?
Yeah.
Which means that I can write it in that way. I write it as x is gonna be less than 2 to the power of what? Minus 3, correct? 2 to the power of minus 3 becomes what? Becomes x less than
1/8.
2 to the power 3. That's so true. Which at the end, you can just write this like that. That x is going to be less than 1/8. Correct, guys?
Yeah.
Fantastic. Fantastic. Now, guys, we aced this problem. We aced this problem. Then for this equation, guys, for the main question which we had, question number 1, which was this logarithm, the solution for this, it is 2 things. First of all, either x is going to be less than 1/8 or x has to be greater than 4. Then we have, look at this, then we have two answers for this logarithmic function, correct? Either x.
And x should be greater than 0.
That's right. That's right. Because in that case, that's so true. That's the very good point that Sean mentioned.
Combine
Sean,
them together.
fantastic. Fantastic job from Sean. Because look at that. Because we have to notice that whatever we have in front of the log, we talked about that also yesterday, Minji.
Yes.
Remember, Brian, that it has to be always positive. Then it means that x has to be at the same time positive. Then let me write it at the next page. Then we can go for the break. Then for these log functions that we had, log x to the base 2 plus log x base 2 power 2 greater than 6, we have to have two criteria. First of all, do you see this color, guys? They're green. Yes, everyone?
Yeah.
The first case is that, as Sean said, x has to always be positive because that's the requirement of the logarithmic function, that the main driver has to be positive. Imagine if this is a Lamborghini car, the driver has to be a positive person. He has to think positively. You can remember it like that. The driver of a Lamborghini car has to be a positive person. He should not be negative. Huh? The second thing that we drive it after playing the hide and seek with this function was what? The x should be greater than 4. And what was the last equation, guys? X, it should be less than?
1/8.
That's right. Okay, we get this one correct. It's going to be positive. X is less than 1/8. And also x is greater than 4. Then these three criteria should be satisfy this inequality. Correct? If x is greater than 4, or at the same time, and at the same time, we can merge them together, that you know that if x is less than 1/8, it should be also greater than 0, the same condition. Huh? You should not go to the negative one. Correct, guys?
Yeah.
Then we solved this one with the hide and seek strategy. I call this strategy that we learned today, hide and seek strategy. Okay, guys? With the case number 3 of the log inequalities. Any questions, guys?
No.
No? Everyone is fine? Mingji,
Yeah.
Sean, Brian, and David just joined us. Okay, then guys, Brian, specifically for you, I'm just gonna post some external link that you can, in the meantime, they are very interesting links. You can learn the basic properties of the log.
Yeah, thank you.
Okay,
thank
David, but please,
That will be
during
fun.
this weekend that we have some time, Friday, Saturday, Sunday, and Monday that the class is off, please watch those videos, huh? Okay, awesome. What time is it, guys?
10.
10.
Oh my God, we passed the break time. Guys, please take 15 minutes break. If you do not have any questions, I see you back, guys, by 10:25 then.
Okay.
Awesome.
Okay.
Enjoy your break, guys. See you soon then.
See you soon.
Thank you.
Yeah.
Hello, everyone. Guys, are you back?
Hello.
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 Okay, sorry, just I hope I'm not late. I just missed the time. Okay, so far, it was page number 6. Okay, now. Okay, guys, let's cover the very last classes of logarithmic inequalities. And tomorrow also, guys, we're going to have a very simple quiz on the logarithmic inequalities. Let's finish this. Then tomorrow, we just take a very simple quiz. Okay. Before we decide on the same concepts that we had, we are going to talk about, it's going to be page number 6. It's going to be page number 7. For this case, guys, remember that previously when we talked about the logarithmic functions, and we said that, for example, if we have something like that, we have a log of, let's say, a function f of x, which has a base b, and it is equal to, let's say, for example, n, we saw that we can just make a representation to the exponential format, and we say that, okay, in that case, I can say b to the power of the n should equal to f of x. Essentially, these were the things that we talked about that a couple of days ago, and it was 2 representations. Guys, imagine that if my case, I have the base which is going to be less than 1. For example, in that case, which I talked about the logarithmic functions, I'm just going to write that the base is going to be less than 1. Correct? We're going to talk about this one as a kind of a refreshing of what we learned before, the case that the base is less than 1. Everyone sees the paper?
Yeah.
Guys, if you remember, when we talk about the base of the logarithm function, which is less than the 1, essentially, it doesn't give us any information unless we just have a representation in the exponential format. You remember that in the exponential format, when we talked about that, we talked of 3 criteria. The first one was that the b has to be a positive number. Do you remember that?
Yeah.
And we said that the b should not be equal to 1. These were 2 basic properties that we talked about the base of an exponential function. And the other thing that we talked by that time was the fact that the b, if b is between 0 and 1, which is essentially the base is less than 1, what did we call these type of functions, guys? Decay functions. Do you remember?
Yeah.
And we said that the case that the b is greater than 1, we call these functions what? Growth functions. Correct? These were the things that we talked about the exponential function, and it was good now that we talked about them right now. But guys, look at that. In case that we have then the base of an exponential function, which becomes the base of the logarithmic function, if it's going to be between 0 and 1, we call that it's going to be a decay case. And that's going to be the focus of our attention at this stage for our logarithmic inequalities. now, guys, imagine that. We are just going to talk about case number 4 of the logarithmic inequalities. And you finish the logarithmic inequalities by this case. Imagine that I have this case, that I have the log of a function f of x with the base b is greater than, I should say, the log of g of x. With the same base, it is similar to the case number 1 that we talked, but the difference is that, guys, a very important difference, that the base is between 0 and 1, the case that we talked about as an exponential decay. Remember that, guys? And now, in that case, what is going to be the conclusion of this inequality? Guys, look at that. Look at the difference of the, can I still say that f of x? I have my f of x and I have my g of x. You see that? Now, guys, look at that. What's happening to this one? I have the same basis. I know that the base cannot be 1. I know that the base cannot be negative and it cannot be 0. And they are equal. And I have my two functions, f of x and g of x. It's similar to case number 1, correct?
Yeah.
But the base is less than 1. Can you still hold the main drivers responsible for this?
No.
No, good. Why?
Because the b value is between 0 and 1.
That's right.
It's a decay function. It's decay.
That's right. Then it means that f of x cannot be greater than g of x, Mingji?
Yeah.
That's right. That's so true. Then, guys, that's going to be case number 4 then. In cases when the base is between 0 and 1, although the base is the same, but the direction of the inequality changes, then in that case, the direction of the inequality gets reversed. Now, g of x becomes greater than f of x. And if you're wondering why, we can think of represented in that case, in that case of the exponential format, and you see that in that case, it is, if base is between 0 and 1, the function is decaying, then it means that it's decreasing. And if the logarithm is, I should say, greater, it means that the reverse is true for the main drivers of the logarithmic functions. It is going to be our case number 4, and it's a very important case in all those 4 cases that we have talked about, the logarithmic inequalities. Okay, guys. Now I'm just going to give you one simple example. Then I just give you one example that you can do it on your own then. Okay, as an example, look at this one, guys. We talked about the log of, let's see. Put this as, I think it could be log 3x. Make it very simple. With the base 1/2 is greater than the log of 2x plus 3 with the base of 1/2. Guys, as an example, can you please look into this equality and try to solve this? I'm going to highlight this one. Guys, are you done?
Yeah.
Yeah, it's very easy, huh? You see that the bases are the same. This is 1 over 2. This is 1 over 2. But the bases are the same, but it's less than 1. Then you say that in that case, 2x plus 3 should be less than, no, greater than 3x, correct? Then as
Yeah.
a result, you say that x is going to be less than 3. Correct, guys?
Yeah.
That's right. And x going to be less than 3. And at the same time, x cannot be 0, because if it becomes 0, then in that case, it becomes the log of the 0 on the other side. In this case, is very easy. You simply just hold the inequalities for the drivers of the logarithmic function. Any questions, guys?
No.
No? Okay. Now let's go. I just give you one last example for today. You solve this inequality, then we should be done and solve Sean's inequality question, which
Yes.
is almost 2 weeks ago.
That's so cool.
Okay. As an example, guys, please look at into this inequality. The log. Let me see. Oh, I got a very interesting case for you guys. Please do this one. Sorry, it's going to be a little bit, I should say, a brutal logarithm function. The base is going to be x plus 4 by 2. That's a little bit, I should say, challenging, guys, but that's a lot to learn from this. It's going to be page number 8. Guys, I have a very interesting questions for you. Please, guys, look into this inequality. This inequality is a little bit different from the other ones which we have solved. And I think that's a good thing that we finish these concepts of the inequality with this example, because we can learn a lot from this. Look at that. The first log, everyone can see what I have written?
Oh, I can see the green. Yeah.
You cannot see the green?
Yeah.
Let me change the color.
Okay.
The green, let me change the color. How about now?
Is it x plus 4 over 2?
That's right.
Okay. Yeah.
Awesome. Guys, look at this inequality. Sean, Brian, David. Look at this inequality. We have the log. The base of the log, it involves a variable x. This is x plus 4 divided by 2. And at the same time, the main driver of this log function is another log function, which is the base 2. But the main driver is 2x minus 1 divided by 3 plus x. And we require the log with the base x plus 4 by, or 2 should be negative. We haven't done yet so far the log functions, which you see the variable x inside the base, and that's a good thing that we can do it right now because we learn a lot. Please give yourself 2 or 3 minutes to analyze this problem, then we do that together. Or if you can solve it, you solve it yourself. Yes, Mingji?
Yeah.
Sean, are you there?
Yes.
Are you solving this?
Yes.
David, Brian? Brian, I think it's a little bit challenging. You can just try that with us, because if you miss some sessions, then this one maybe is not an easy one for you.
Yeah.
You can do that with us.
I'm trying.
Who is done, guys? Guys, are you done? Let me take the first step, then you can continue after, huh? Hello?
Yeah.
Yeah.
Who is done, guys? Ningji?
Not yet.
Sean? Sean?
Yes.
Are you
Oh,
done?
not really.
Okay. Guys, as a first step, I'm gonna advise you, you have to take 3 steps. The first step is that you have to look at the function itself, find the outer boundaries of this inequality. Because you see a base and you see a function, the first thing, 2 things that you have to look into that is that the first thing, guys, is that when you look at the function as a logarithmic function, let me write it here. When you see a logarithmic function, the log of f of x with the base x, for example, correct? Then you have to do 2 things. First, you establish 2 conditions. The first condition that you establish, guys, is that the main drivers, the main arguments of the inequality has to be positive. F of x has to be positive. What is the other argument, guys? It's about the x. Also, at the same time, x should be positive. We talked about this case before. Do you remember? The base, we said that the base has to be positive and base has not to be equal to 1. Do you remember that?
Yeah.
Correct? Then at the same time, x should not be equal to 1. Correct?
Yeah.
The first step which you do is going to be this. You come here, say, okay, the main arguments of the f of x should be positive, and at the same time, the base also has to be positive and it should not be equal to 1, because we learned these 2 criteria 2 weeks ago. Then when we talked about the exponential functions, that the base of an exponential functions, which act as a base of the logarithmic transformation, should not be equal to 1, or at the same time, it has to be positive. When you guys, you meet these 2 criteria, the other way which to solve this is that look at the base. Remember that exponential function, we said that decay exponential and the growth exponential, when the base is between 0 and 1 and the base is equal to greater than 1. Then from these 2 cases, you look at the function itself. You say that the log of 2x minus 1 divided by 3 plus x has to be positive, huh? Because the main argument is the log. If it has to be positive, there is another sub-argument that 2x minus 1 divided by 3 plus x has to be positive because this is the main driver of the log function which has the base 2, correct?
Yes.
Yes, guys.
Yeah.
And at the same time, you look at the base of this function, the base is 2, which is, it satisfies this requirement because at the same time that the base is greater than 0 and at the same time 2 is not equal to 1. Then we are totally happy with the base of this function, which is 2, correct? But at the same time, we go back to the base of the first log function, which x plus 4 divided by 2. Huh? Then we say that x plus 4 divided by 2 has to be positive, and it should not be equal to 1. When this base gets equal to 1, guys, x plus 4 divided by 2. When this gets equal to 1.
When x equal to -6, it
Negative
will
2.
equal to.
Because
yeah,
if
negative
x
2.
gives you negative 2, you put negative 2 plus 4 becomes 2. 2 divided by
yeah.
2 becomes 1.
Oh yeah.
Then the
Negative.
first thing you notice from the domain of this function is that x can be anything at this moment, but it should not be equal to -2, because if it gets -2, then the base of the log function becomes 1. And that's a bad thing because we do not want the base of any log function equals to 1. We in the entire math, we do not have any log functions which its base is equal to 1. That's right. Guys, if you see in the entire math a log function which its base is equal to 1, let me know. I give you $1 million. Okay? It's like as if you see a man with 3 eyes. It's impossible. And at the same time, this has to be equal, it has to be positive. When you meet these basic requirements of the log function, which the main drivers has to be positive, and its base should not be equal to 1, and at the same time positive, you have some intervals for this function. Now you have to do some kind of minor divisions. And minor division is what? You look at the base of this function. That if x plus 4 over 2 is decay or x growth, if it's x plus 4 over 2 is bigger than 1, or if x plus 4 divided by 2 is less than 1. That's right. Then you have, after this preliminary step, that the main driver should be positive and the base should not be equal to 1 and at the same time positive, you get 2 more steps to take. You have to look at the case that the base is greater than 1, that the function represents the decay, the growth, or the base is less than 1, that it represents the decay. Then in that case, you have to find arguments on the 2x minus 1, 3 plus x. Then as a result, you have 1 main step to take and 2 extra steps to take with respect to this one. That's right. I'm just gonna, guys, give you this one as a homework. Please, it takes a little bit trick to solve this one. Please solve this one on a piece of paper and correctly classify this. And at the end of your homework, show the intervals on the x-axis. Correct? And please submit it to me, email it to me today before you go to bed. Okay? Then tomorrow, I'm gonna solve it here for you, and then the rest are just joining us to solve it and see. This question is a very interesting question to solve it. Okay?
Okay.
Okay.
Please, guys, remember, email it to me before you go to bed. If you can email it to me on the Schoology website, even this is much better. Okay?
Today we also need to email you the weekend homework, right?
That's right. Are you done with it?
Okay. Yeah, almost.
Awesome. Awesome. That's fantastic. It was lots of questions, but it's a good thing to learn these kind of stuff, Mingshi. Fantastic. Then you have 2 things to submit to me. Then please also look into this one. This is a very interesting question, guys. Very interesting. I should say the best inequality which we have solved yet. Sean, did you solve it?
Yes.
You solved
I'm
this
sorry.
one? You solved
Uh,
this one?
This one is not that hard.
Okay. It has lots of steps to take.
Yeah,
And
just
please, Sean,
using the
please, Sean,
calculation.
yeah, please email it to me. And but I prove to you, Sean, it's so hard.
Really?
Tomorrow I solve it. I show you that it's so hard.
Okay, I will solve this.
Yeah, yeah. And Mingje, please email it to me, David and Brian. And Sean, please also just have your question for sure for tomorrow.
No problem.
Yeah, oh my God.
100%.
That's right. Tomorrow we're going to solve it eventually then. Then, guys, then I should say we are done almost today. If you have no questions, tomorrow I'm going to solve it myself into the class and also for the rest of the students. Then also make sure that today you submit your homework, which is due for today to me. And at the same time, do this one and email it to me then. Okay?
Okay.
Awesome. Awesome. Any questions, guys?
No.
No? Then I see you guys tomorrow then. Enjoy your day then.
See you.
Awesome.
See you.
See you
Have a
tomorrow.
good day.
you.
Take
See
care.
you.
Bye. Bye,
Bye.
Mingje. Bye,
Bye.
Sean.
Bye.
Bye, David. Bye, Brian.
Bye.
Bye-bye, everyone.